Electrostatic speakers can do special sonic things, and perhaps no manufacturer has done more in the past few decades to bring these special sonic attributes to the consumer than Martin-Logan. Today we'll take a look at some of the early history of the company, with some reflections on personal experience and excerpts from an interview with founder Gayle Sanders. I hope you enjoy it. Those of us who've been in the audio business for decades can almost always tell you about seminal or life-changing audio experiences they've had. Usually, these involve hearing a new piece of gear that allowed very different and mostly better experiences, generally getting closer to the absolute sound. Reviewer John Vallon and I share this experience of the Magnaplanar Timpani 1D. I've also discussed here on our YouTube channel my experience with IMF transmission line speakers. Then, the Audio Research SP3A wrought some similar impressions, in my case demonstrated by Dan D'Agostino, who went on to found Krell and D'Agostino Master Audio Systems. And that brings us to the Martin-Logan CLS. It delivered a level of sonic transparency that was frankly astonishing. I should back up a bit to explain this. Electrostatic speakers create sound in a different way than normal cone-type speakers. In both cases, a diaphragm is used to move the air back and forth to create the sound waves that your ear and brain can hear. But a cone speaker moves the cone by pushing it near the center with a wire voice coil. The voice coil is in a magnetic field, and the electric signal from your amplifier runs through the voice coil. When electrons flow back and forth through the wire in a magnetic field, the voice coil moves back and forth, pushing the cone back and forth. A lot of back and forth. The cone must be stiff to minimize distortion across its surface because it's only being pushed at this one area near the center. In an electrostatic speaker, we have a thin, flexible diaphragm instead of a cone. The diaphragm is usually made of polyester film. The film is coated with a conductive material. This conductive material is charged to a high, constant level. This is why electrostatic speakers are almost always plugged into an AC socket. In front of and behind the diaphragm are two metal grids called stators. The stators get the music signal from the power amplifier, and the varying voltage attracts or repels the charged diaphragm to move the air at the frequencies of the music so that your ear can hear it. Several elements tend to result from this. First, the electrostatic diaphragm is driven across its entire surface. This allows the diaphragm to be lighter because it doesn't have to resist bending from a force applied at just one place, i.e., as I said before, the apex of the cone. F still equals ma, so the theory suggests that electrostats could be more responsive to small signals. Second, partly for historical reasons, cone speakers have tended to be placed in a closed box, and electrostatics have tended to be set up in a dipole arrangement where the sound emanates from both the front and the back of the speaker. Dipoles have various advantages and disadvantages, and dealing with the disadvantages while preserving the advantages is the foundation of much of the history of electrostats. In the early days of modern audio, which I'll say is the 1960s, you might disagree, but let's just use that as a reference point, two great electrostatic speakers were developed and marketed. The first was the Quad ESL 57. It was a short, wide speaker, kind of looks like a radiator in a way, that was the source of many an audiophile's aha moment. Beautiful mid-range, a significant bass roll-off, and very strict and low volume limits. If Helen of Troy had the face that launched 1,000 ships, the Quad ESL was the speaker that launched 1,000 audiophile journeys. The other great electrostat of the 1960s was the KLH-9. Designed by Arthur Jansen, it was a big and expensive endeavor to get around the limitations of the quad. Unfortunately, KLH had a brilliant design team but needed funding to grow, and, well, the Singer Sewing Machine Company perhaps didn't fully comprehend the marketability of a $2,280 speaker in $1968. That's about $25,000 per pair today, just for reference. And so production was eventually stopped. J. Gordon Holt, I'm wearing my J. Gordon Holt memorial glasses for this purpose, reviewed the KLH-9 in stereophile in 1966 and we'll put a link to that review in the description. It's really worth reading. One excerpt to flesh this epic saga out from JGH. This was the first time since we started dabbling in high fidelity in the early 1940s that we have ever felt we were really listening through a loudspeaker instead of to it. The KLH-9 system has a degree of transparency and detail that we simply did not believe possible, which, as you might expect, brings me to the Martin-Logan CLS. It was released in 1986, fully 20 years after the KLH-9. As happens often in technology, much of the period of wild invention, let's say 1960 to 1975, is followed by a period of technological refinement. The CLS landed in the market after a decade or so of useful refinement. It landed on a group of audiophiles, many of whom had missed the short-lived attempts at state-of-the-art designs like the Quad, the KLH-9, the Dayton Wright, the IMF, and the Timpani 1D. I first heard the CLS at Audio Consultants in Evanston, Illinois. It was priced at $2,490 per pair, which is about $7,000 in today's money. I hadn't read JGH's review of the KLH-9, but the same feeling hit me like a ton of bricks, listening through the speaker to the source instead of listening to the speaker. This was so obvious that it didn't require effort or 100 tracks to find it. This transparent quality was just there. But because the CLS had the standard dipole bass roll-off and maybe some brightness in the upper mid-range or lower treble, again, those darn ships set sail for Troy or wherever audiophile wars are fought. Now, let me at this point join Dick Olsher's discussion of Martin-Logan history from the Absolute Sound's Illustrated History of High-End Audio. He says, the early years of Martin-Logan were focused on experimentation with conductive coatings, insulation, adhesives, perforated steel stators, all elements needed to make the speakers reliable and capable. And, of course, founders Gayle Sanders and Ron Sutherland worked on the curvilinear line source panel, CLS, to improve dispersion. Don't confuse, by the way, CLS, the curvilinear line source, with CLS, the model that we've been talking about. They're related but not the same thing. The septual breakthrough, and is now a fixture in every Martin-Logan electrostatic design. Some said that a curved panel wouldn't work, but we're all grateful to Martin-Logan for exploring the road less traveled. Over the years, Martin-Logan strove to improve its core technology, the electrostatic transducer, by continually researching new materials and methods to improve conductive coatings, insulators, adhesives, assembly processes, and so on. This continued evolution has resulted in improvements to bandwidth, efficiency, consistency, and reliability. We'll talk about that more in a moment. The electrostatic panel of 1983, while looking similar, is vastly different from its contemporary counterpart. For example, in 1983, conductive coatings were hand-applied with a conductive slurry. Today, conductive coatings are applied to the diaphragm via a proprietary vapor deposition process in a state-of-the-art vacuum chamber that allows the diaphragm to maintain a 5,000-volt charge. What motivated all this experimentation was that audiophiles wanted, and still want, full-scale reproduction of both dynamics and bass response. After significant experience with all variations of both ESL and dipole technology, Martin-Logan had to face the reality that dipoles, and ESLs in particular, are challenged when asked to reproduce large-scale dynamics and low-frequency information at the same time because they have excursion limitations and they have dipole radiation. So, Martin-Logan decided early on to design a high-efficiency electrostatic transducer to be integrated into a hybrid system. That first speaker was the Monolith, and it launched the company following an encouraging reception at the 1983 CES. Sales took off in 1985, placing the company on firm financial footing, and it was also when Ron Sutherland departed Martin-Logan to pursue his first love, electronics, which he's still doing. The first full-range electrostatic speaker, the CLS, arrived in 1986, as mentioned before. That appealed greatly to experienced audiophiles, but it was the sequel, another model, a smaller hybrid introduced in 1987, that resulted in explosive sales. During the 1990s, product releases came fast and furious and included some of Martin-Logan's classic models such as the Quest, the Arius, the SL3, and to top off the product line with a claim to state-of-the-art honors, the massive Statement E2 loudspeaker, which was released in 1998. The release of the Summit in 2005, followed by the Summit X or 10 in 2009, heralded the arrival of the most advanced hybrid yet, combining dual independently powered woofers with Martin-Logan's most advanced electrostatic transducer to date, the XStat. Extending the history of extreme purist models, the CLX Art, unveiled in 2010, was its most advanced full-range electrostatic. Now, I want to switch gears a little bit here and talk about an interview that Dick Olsher did with Gayle Sanders on the early years of the company. I think this is kind of fun. I'll be reading Gayle's words just to avoid confusion here, as well as the questions that Dick asked, because we didn't record it in video back when we did it. When did you first become passionate about music as well as reproducing the live experience in the home? Music was part of my life since I can remember. In my family, there was always piano and singing and records from classical to rock to jazz and blues. I got into performing early, first in an a cappella choir and then in folk, jazz, and finally rock groups. I played professionally from the age of 13 on through college, where I worked with a small number of jazz ensembles and rock bands of all shapes and sizes, paying for the majority of my college expenses. As we understand it, you met up with Ron Sutherland in the late 70s. What brought you together and led you to trying to build a better electrostatic speaker? When Ron and I first met, we shared a common interest in music, and despite our different backgrounds, we quickly became friends. I was a musician trained in architecture and advertising. Ron was an electrical engineer and a degreed physicist. We soon discovered that we also shared a passion for developing audio designs. I told Ron about my dream of creating a real electrostatic loudspeaker, and he immediately jumped in. At the time, I had developed a basic ESL transducer. It wasn't pretty, but I was close to actually making it work. Ron had just the right talents to help me achieve that. That's what brought us together to start Martin-Logan. So in 1979, Ron and I organized a small design team committed to overcoming the many difficulties that came with electrostatic speakers. Though by this time, the efforts of some incredibly skilled engineers had resulted in some very good electrostats, no one manufacturer had completely resolved the puzzle of how to perfect them. I was naive enough to think that I might just be the one to crack the code. ESLs had the reputation for being bass shy, easy to blow up, extremely amplifier critical, beamy and directional, and let's not forget, hampered by significant SPL limitations. Even with those limitations, when one listened to a well-designed ESL, the jaw-dropping transparency and you are there ability of this lovely technology was addictive. I was convinced these problems were a result of engineering and materials application of the day and could be overcome. In all my research, it was clear that the physics behind ESLs had few limitations if only one could find the right materials to control the sometimes terrifying technology, and if one knew how to work with the specific requirements of a super high voltage low mass system. Please describe the early years of experimentation that led to the first ESL prototype, circa 1990. It was my classic entrepreneurial story. My lab, I use that term very loosely, consisted of a makeshift desk made out of an old door resting on a pair of sawhorses. Sitting in the corner of my garage, equipped with a rotary phone, pencil, pad of paper, a stack of ideas, and a bunch of tools, some of them handmade just for the project, I began talking to scientists and engineers who might be able to help me. Many became fascinated by the project and offered useful suggestions, and the lab quickly developed into a working shop outfitted with the raw materials I would need to prototype an advanced electrostatic transducer. After 6 months of building prototypes, only to have them fail time and again, I finally had what I thought would be the first working transducer. God, it was ugly, but I loved it. By that time, Ron had joined me. In a very short time, he designed the transformer and power supply based on the transducer's electrical properties and the efficiency we had determined it could potentially deliver. It took many more months before I devised a perforated metal structure with sufficient efficiency and rigidity, sourced from the optimal film for the lowest mass structural integrity, and found material and adhesives for spacer elements that had the necessary insulating properties and tensile strength. For the prototype, I only needed to make the diaphragm surface conductive, so I smeared a concoction of graphite powder and my own personal magic dust on the diaphragm in order to energize the surface uniformly. 4,000 volts. Yeehaw! I encoded the metal panels with RID arc, hoping that it would be enough insulation to allow the system to actually perform without blowing up. Then the moment had come. We anxiously hooked the interface transformer to my trusty Hafler DH100 amplifier. I can't remember the preamp nor the turntable, but I do remember when we first dropped the tone arm onto the record. Was it Joni Mitchell? Maybe. All I can remember is that at that moment, the most magical music flowed from that object. It was everything I had dreamed. The curtains pulled back, and transparency incarnate presented itself. Ron and I were both at once yelling, crying, and hitting each other. Then I uttered those fateful words. Let's turn it up. At once there was a loud explosion. As I gawked, a ball of flame engulfed the transducer, and then silence, followed by a blue-gray puff of smoke that lingered in the room to remind us of how naive we were and of the dangers that lay ahead. My poor Hafler had a puff of smoke lingering above it, too. It was very quiet. All you could hear was the mechanical scratching of the stylus through the record grooves. I lifted the tone arm. Maybe tomorrow. Improving horizontal dispersion must have been an R&D priority in those days. How did the curvilinear line source, CLS, transducer central to the design of every Martin-Logan electrostat come into being? After we had developed a rugged, no-compromise transducer, we still had to solve the significant dispersion problem that all large surface transducers pose, specifically that the higher frequencies become progressively narrower and narrower in dispersion. The result is that only one person can experience the full frequency range, and that person can't move. It's so limiting that the phenomenon has become known as the head in the vice listening experience. One evening, Ron and I were debating how a point source wavefront behaved at higher frequencies compared to one that radiated from a relatively large surface of our diaphragm. Ron began diagramming a progressive arc that became more and more curved as it moved forward in time and space. That was the aha moment for me. Could it be that simple? Could one simply mechanically mimic that arc in space to get uniform dispersion? I set to work that night to make a jig to both curve the diaphragm and stator elements in as exacting a way as possible. The next few days were spent refining the fabrication process. Finally, we had the first curvilinear ESL transducer. The results were just what the doctor ordered. We had uniform horizontal dispersion, yet it was well controlled in both the vertical and horizontal plane, minimizing and offering even better control than the point source as it behaved in the room. When did you finally feel secure about your business decision? That took a while. I had worked so hard for 3 years to create the monolith, but now an entirely new struggle was about to begin. For the next 3 years, the fledgling company faced every teething pain you can imagine. There was no relief. 100-hour weeks, product failures, cash flow crises. We faced bankruptcy on a regular basis. The only time I could take a breath was to lock myself in the bathroom just to lift the burden for a few minutes. On one particularly bad day, one of the real high-end founding fathers called me. Out of humility, he probably doesn't want me to mention his name, but let's just say there was a time when he made amplifiers in a coffee can. Anyway, he asked, "So, Gayle, how's it going?" I was in no mood to BS that day and asked if he wanted the truth. "Let me have it," was his response. I proceeded with a litany of painful retorts. "That's just not right," came the voice over the phone. "How much do you need to get through?" I told him a hefty number, to which he responded, "Check's in the mail." The next day, the money was direct wired to the Martin-Logan account. That saved the company. One of my best days was many months later when I was able to finally pay that money back. Work really heated up on a smaller hybrid we called the Sequel, and finally, the day came that Martin-Logan introduced it into the world. It was just the right speaker for the times, and it took off with explosive sales. Once we released the Sequel, it was like a powerboat planing out. Things got smooth. The ML team now was a well-oiled machine and could execute with ease. Cash flow became positive, so finally, after 6 years of sacrifice and struggle, life became fun. ML started to rock and never looked back. As you look back over an audio career that spans over 30 years, which highlights jump out at you and which milestones are you most proud of? I remember walking the halls at the '82 CES convention and thinking, hey, I'm one of the new guys in the industry. It was an exciting time, and great companies were coming into being. We were all consumed with our vision, and together created an exciting, engaging, superior standard of excellence in performance. As an industry, we avidly read J. Gordon Holt and Harry Pearson's words on the journalism side as we crafted and perfected our products. It was a generation of young renegades out to change the face of sound reproduction, and it was a wonderful time in which to create. Naturally, that first moment when I integrated the first working high-efficiency stat panel and a high-performance woofer, the predecessor to the Monolith, was thrilling. We were in a small listening room. It had been years in development. Immediately, the transparency and slam was jaw-dropping. I had only experienced that moment of wonder with the Infinity servostats before. I'll never forget that feeling. I was stunned. That moment showed me that I truly had something to contribute to the audio industry. Toiling away in that same room night after night, a few years later, resulted in the creation of the CLS. I couldn't wait to share that with the world. And finally, the moment the sequel entered the market, I knew we had a true winner. The right product, the right price, the right time. A true commercial success. And to see Martin-Logan's success sustained over the years by the team of talented and committed young men and women that I've trained and mentored, that's enriched those memories in the most satisfying way I can imagine. Now, with that interview in mind, and with the discussion of the CLS and the Monolith and the sequel, let me just share with you, to close this out, a few quotes from reviews of Martin-Logan products in the Absolute Sound. For me, this is a trip down memory lane. I hope you'll enjoy it too. First, quotes from our CLS review. Overall, then, the Martin-Logan CLS withstands the test of time in exemplary fashion. Its only significant shortcoming is the lack of deep bass. Other than that, it's a world-class speaker system. That's from John Nork in issue 46. About the sequel, quote, dollar for dollar, I consider this the best speaker in high-end speaker systems. It represents the mating of an electrostatic mid-range high-frequency panel with a conventional ported enclosure containing a conventional cone-type woofer. I'm told that dealers sell this speaker almost before it's unpacked, and I can well understand why. If I myself were on a budget, it would most likely be, with some reservations, the speaker I would choose to live with. Harry Pearson in issue 57. About the CLS2, quote, Sanders has done his homework. Today's Martin-Logan is a force in high-end circles, just the way Magnapan was a decade ago. The CLS2 is aesthetically neat and sensible, fascinating and serious, musically brilliant. Andrew Benjamin in issue 62. Then about the sequel 2. The Martin-Logan Sequel Series 2 loudspeakers come as close as anything I've heard to succeeding at the gnarlesome enterprise of fusing a cone woofer with an electrostatic panel. The things really do display the transparency of the latter with the taut control of the former, and pretty seamlessly at that. Fred Kaplan in issue 64. Then about the Source. How does the Source sound? In a word, terrific. This one is very quick, very high resolution, surprisingly robust, wideband, and coherent, capable of making select voices and instruments sound as you are there real as some multi-$1,000 big boys. If you haven't heard a Martin-Logan electrostat in a while, you kind of forget how astonishingly lifelike they can be. Despite the fact that all stats use the same basic drive system, panels from different companies sound as substantially different as dynamic loudspeakers from different companies. Logans are fast, and transparent, as in clear, pure, uncolored. Hearing plucked guitars or violins played back on CLSs always made everything else, even other stats, sound slightly stuck in the mud. It's no different with the Source. Only the Source is far more realistically dense in tone color and far more full-bodied and three-dimensional than the old CLS. Jonathan Vallon in issue 180. Then, about the CLX. I've never heard a loudspeaker that's as transparent as this one. John Vallon in issue 190. I hope you've enjoyed this early history of Martin-Logan. Thanks for watching, and we hope to see you again soon.